Okay, so we only need one of each one of these that we need to describe. There are different ways in which we store our data and we access our data. Okay? The global variables from your object-oriented stuff are the fields. They're the properties of your objects. Okay? So what I've done is I've listed them. This is where you can find them. In-game setup, there's something called score. Okay? It has to be global because we need to access it from more than one place. We display the score on the screen. Okay? That's done by one routine, one method. But we also need to update the score when we kill a brick. And that's done by a different method. So it has to be accessed in two places, so we make it global. Okay? So all these are the same. So we've got current level. That tells us what level we're on. We've also got how many lives. And again, we're displaying that on screen, and we're also adjusting it somewhere else. And then the brick count. Okay, that's in level, that's keeping track of how many bricks we have produced. So that we know when the game's ended because all the bricks have gone. Otherwise you wouldn't know when you've got the last brick. Okay, so that's global variables. So they're accessible in multiple places. We've also got, and not many of them to be fair, these are all the ones that I could find. We've got local variables. These are temporary. They're only used during a method while it executes, and then they're thrown away. They're destroyed. So we've got include level. We've got this little dummy variable that is used to hold a sprite. That's got some settings for our text because we want the text to die, and dummy sets that up. So as soon as that's been used, it's gone. We also use the rows and columns to work out where we're putting the bricks. Okay, and that isn't needed beyond that code, so they get destroyed again. So they just exist for temporary storage. Okay, the next lot, the static ones, they need to be accessible all over the game. And you'll see that most of these, in fact all of these, have got GM in front of them. That's the global game setup code. Okay, generally it's all stuff to do with my engine. So we've got the screen size so that we can check anywhere what the dimensions of the screen is, so we know where the right hand edge is, top, bottom, left. We've got, if you messed about with the graphics, you'll have looked at the sprite one. This holds like graphics that you want to use for your game. Obviously in your final games you're going to have your own graphics for lots of things. Okay. Throttling is to do with the speed of the game engine. By default it is locked to the speed of the screen refresh, which is 60 Hertz. Okay, but you can, if you find that line and you set throttle equals false, that will make it run as fast as it can. For that Breakout game, that will probably translate to about 1,300 frames a second, which is like rubbish, but it's very, very, very fast. It's not doing anything. Okay, when it comes on to these ones, the obvious one is the input manager. It does all the input code for you. So that checks the keyboard, checks the mouse, and it'll check gamepads if you've got your Xbox pads plugged in. The text manager is used to do anything to do with drawing text. The event manager is to do anything to do with time. And the engine manager is basically the big boss. It does all the work with sprites and actually bosses all these other ones around, actually. Okay, that is the main part of the game engine. Okay, so they're all static so that we can access them from anywhere. That's what generally what static means. And then the last bit, the last two bits, overloads. This is one of the nice features of object-oriented programming. We have got in various places this code, text manager.draw. That's for drawing text on the screen, dynamic text that changes every frame. But we have actually got a couple of different ways in which it works. We can supply it with a font, the text we want to draw, and the position on screen, or we can supply it with font, text, the position on screen, and how we want it to look. But the names are the same, and this is what we call overloading. What it allows you to do is have a consistent, you say I want to draw something on the screen, the name doesn't have to change. If the data that we pass to it is different, we can use the same name. It's doing the same job, so we keep the same name. Rather than draw text just at a position, and we'd have to call this one draw text with attribute, which would be stupid. Makes it complicated to use. There's less to remember. Okay? In the same way that when you're doing normal programming, we have plus, and we can add two integers together, or we can use plus to add two floating point numbers together. And these are actually, to the computer, these are different things, but we still use the plus. Okay? If you had to say plus integer or plus float, it would be horrendous to use. Okay, so overloading is actually quite useful from that point of view. We've got a similar system with a broadcast. We can actually just broadcast just a message type, or we can actually broadcast and pass some data as well. Okay, it depends on what it is. So this was for when the scoring. So we broadcast the score of the brick. Okay. Right, and then the last bit, object instances. Wherever we create an object, you can always spot this in most object-oriented languages because you use this keyword, new. So just look through your code and find anywhere where you've used new, just to do a Control F and search. Obviously this one creates an instance of the paddle class, this one creates an instance of the ball class, that one creates an instance of the level class, that's that dummy thing that created a sprite so we could do some settings, and then this one created a brick. And if you ever see anything like this where you've got an equals, what you're meaning is, right, okay, create it and let me refer to it using that name. That's all that means. Okay? Right, stop that one. Right, so I've got one more video to